Next we're going to look at expanding higher powers for the binomial distribution. Using Pascal's trunk doesn't work, so we really need a different method. In order to use this method, we need to know a little bit about what's known as permutations and combinations, in particular combinations. So we're going to look at this from this example. From the letters A, B, C, D, E, consider the number of ways of filling in 3 empty spaces. So we've got 1, 2, 3 empty spaces. So if we consider those spaces, and maybe you can just pause the video at this point and think, how many ways can you fill the first space in? Having filled that in, how many ways can you fill that in? And then how many ways can you fill in the third space? Now, there are 5 letters to choose from, so there are 5 ways I can fill in that first space. Now I've used one of the letters, so there are now only 4 ways of filling in the second space. I've now used 2 of the letters and now only have 3 left to choose from for the last space. And the number of ways, total number of ways, will be 5 times 4, which is 20, 20 times 3, which is 60 ways. So the number of ways will be 5 times 4 times 3, which is 60 ways. Now this has a special name. This is called the number of permutations. So this is called the number of permutations of arranging 3 objects from 5 objects. So that's called 5p3, that's the notation, and you'll find a button on your calculator for this, normally above the multiplication sign. So there's 60 ways. Right, I want to look at this a little bit more closely to see if I can come up with a formula for permutations. So 5p3 is going to be 5 times 4 times 3 is equal to 60 ways. Now I could have written this, and maybe you didn't think of it, as 5 times 4 times 3 times 2 times 1. Now if I do that, then I've got to divide the bottom by 2 times 1. Now doing 5 times 4 times 3 times 2 times 1 has a special name. It's called a factorial. And we have a symbol for that, 5, and it's actually an exclamation mark, okay? And there's a button for that on your calculator. And then along the bottom we would write 2 factorial. So this is the term, it's called factorial. And 5 factorial means 5 times 4 times 3 times 2 times 1. 10 factorial will be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 1. Note, n factorial will be n, 1 less than n, 1 less than 2, 2 less than n, all the way down to 3 times 2 times 1. It is more useful to write this 5p3, because we've got 5 and 3 here, to write this as 5 factorial, and then as the denominator we write 5 minus 3 factorial. Or more generally, NPR, so n was 5 because we had 5 letters to begin with, so we would have n letters, and we're going to choose r letters, so it will be n factorial over n minus r all factorial. The number of permutations of arranging r unlike objects from n unlike objects is written as NPR is equal to n factorial over n minus r factorial. Okay, but for our binomial expansions we're going to need to look at combinations, so let's look what we mean by that. So if we consider we had to select ABC, we had selected ABC into our 3 empty spaces, how many different ways could we actually do that? They could have been selected in any order. So pause the video and see if you can write down the different ways that we can write down the letters A, B, C. Did you come up with, so if we list them, ABC, ACB, maybe not necessarily in this order, BAC, BCA, CAB, and CBA. That means that gives us 6 possibilities. So for a combination, these are considered as one arrangement. Alright, so these 6 are called 6 different permutations, but they're only considered to be one combination. It doesn't matter which way we write them down for a combination. And this is more useful for the binomial distribution, expansion. So each combination in our empty space is problem gives rise to 6. Now 6 can be written as 3 factorial permutations. So the number of permutations is going to be the number of combinations times 6, or times 3 factorial. This is written as 5 factorial over 5 minus 3 factorial, and this is written as 5c3 is times 3 factorial, because we are for each one of these there are 6 permutations, so for them to be equal we have to put times 3 factorial. If we divide by 3 factorial, we get that 5c3 is going to be equal to 5 factorial over 5 minus 3 all factorial, 3 factorial. If we had n and r, then the general formula would be NCR is equal to n factorial divided by n minus r factorial, r factorial. Now you should be aware that NCR has different ways of writing it. One alternative way, and they use this in the International Baccalaureate, is NCR. It looks a bit like a matrix, but it isn't. And the same formula, n factorial, n minus r factorial. Slight mistake there, let's just change that. Sorry, n minus r all factorial, r factorial. Okay, so this is our general formula. Therefore 5c3 is 5 factorial, 5 minus 3 all factorial, 3 factorial. Now, that's 5 times 4 times 3 times 2 times 1 over 1 times 2, 3 times 2 times 1. Do a bit of cancelling, and we end up with 20 over 2, which is there's 10 combinations. Okay, which makes sense. There were 60 permutations, and there are 6. If we divide that by 6, we get the number of combinations. Okay, say we wanted to select a team of 3 from 3 players. Now logically there's only one way of doing that. Okay, so we know there's only one way to do this. So that's 3c3. According to the formula, that's 3 factorial over 3 minus 3 factorial divided by 3 factorial. That's going to give me 3 factorial over 0 factorial times 3 factorial. Well, that divided by that will give me 1, so that means that 0 factorial has to be defined as 1. And that's an important fact to know, that 0 factorial is defined by 1. So this has been a video to show you what a combination is, basically. Although we talked about permutations, you need to know what a combination is in order to go on and look at the binomial theorem. I hope you've understood, and I thank you very much for watching.